Chapter 4, Section 7, More Fractional Equations and Applications. The only difference in this section and the previous section is you may need to factor the denominators before finding a common denominator to eliminate the fractions. So let's look at this first fraction, or this first equation. If you notice, look at the denominators. For this one, I'm going to have to, for the very first one, I'm going to have to factor out a 2. And I'm going to get x minus 4. And for the second one, this is the difference of 2 squares, so I'm going to factor into x plus 4 and x minus 4. So what happens is I get a totally new equation. Well, I get a new equation, but it's just manipulated. Okay, and so now what we need to do is we need to pick out that common denominator. And the same process, you've got to use everything once and only once. So I see 2's, I also see x minus 4's, and I see x plus 4's. And so that is going to be the common denominator. So what we're going to do is we're going to multiply this whole entire equation by that common denominator. So, when I multiply this first fraction by the common denominator, the 2's will cancel out and the x minus 4's will cancel out, and I'm left with x times x plus 4. So I have to multiply this x plus 4 times this x. When I multiply the common denominator times the second fraction, the x plus 4 and x minus 4 cancels out, and I'm left with 2 times 16. And when I multiply the common denominator times 1/2, the 2's cancel out, and I'm left with x plus 4 and x minus 4. And it doesn't matter how you write this because multiplication is commutative, so I know that I wrote x plus 4 first where I have x minus 4 here, but multiplication is commutative. Same here. So now what I'm going to do is I'm going to use the distributive property and get rid of all these parentheses. So x times x is going to be x squared. X times 4 is going to be 4x. 2 times 16 is 32. And then when I multiply x plus 4 times x minus 4, I'm going to get x squared minus 16. Alright, so if I start solving this equation, I know that I have a quadratic, so I need to get both of those on the same side. So if we move the x squared over, you'll notice that both of them go to 0. So that eliminates the quadratic. So I have 4x plus 32 is equal to negative 16. And now I just have a regular linear equation. So I'll minus 32 from both sides. And I'm going to have 4x is equal to, negative 48. And then if I divide by 4, I'm going to have x is equal to negative 12. So again, the only difference is we're going to factor first, then find the common denominator, then multiply through by the common denominator. So let's look at this problem. The two fractions on the left will not factor, so they're good. But the one on the right, it's a trinomial. There's nothing in common. The leading coefficient is 2. So I need to do bottoms up. So I'm going to multiply. I'm going to go to the other side. So I'm going to multiply the 2 times the 5. So I'm going to have 2 times 5 is 10. So we'll have n squared minus 9n minus 10. And when I factor this, I'm going to have n minus 10 and n plus 1. And then I'll divide that 2 back out. And so I'll have n minus 5 and 2n plus 1. So notice that this trinomial factored into the two binomials that were on the left, which is convenient because now that is my common denominator. So my common denominator is going to be, remember you have to use everything once. Well, I see a n minus 5 and I see a 2n plus 1. So that is going to be the common denominator. So I'm going to multiply this whole entire fraction by that common denominator. And when I multiply this first fraction times the common denominator, the n minus 5s will cancel each other out, and so I'm left with 3 times 2n plus 1. And if I multiply this second fraction times the common denominator, the 2n plus 1s will cancel out, leaving me with negative 2 times n minus 5. And when I multiply this last fraction times the common denominator, all of these, the n minus 5 and the 2n plus 1, will cancel out, leaving me with n plus 3. Alright, so the fractions are gone, and we're just going to use normal solving equation techniques, distributive property, to get rid of the grouping symbols. So we'll have 6n plus 3 minus 2n plus 10 is equal to n plus 3. Combine like terms, and we'll have 4n plus 13 is equal to n plus 3. So let's move this n over to the left, and so we'll have 3n plus 13 is equal to 3. And then if we minus 13 from both sides, we'll have 3n is equal to negative 10. Divide by 3, and we have n is equal to negative 10 thirds. Alright, this one we don't have to factor, so it looks like an equation from the previous section. So our common denominator, remember we have to use everything once, and I'm going to write that 2 first just for simplicity, and then I have an n plus 1 and an n plus 2 group. So that is going to be the common denominator. And I'm going to multiply this whole entire equation by that common denominator. So when I do that, with the first fraction, the n plus 1s are going to cancel out. So I'll have 2 times n plus 2. And I like writing it this way. I like having my monomial out front, so I'm going to have 2 times n plus 2. Plus, when I multiply the common denominator times the second fraction, the 2's are going to cancel out, leaving me with those two groups, n plus 1 and n plus 2. And then when I multiply it times that last fraction, the n plus 2's cancel out, leaving me with negative 2 times 2 times negative 2, which is going to be negative 4, times that n plus 1. Okay, let's use the distributive property. 2n times n is going to be 2n squared, and 2n times 2 is going to be 4n. Here we're going to fold this out, so we'll have n squared plus 2n plus n plus 2. And here we'll distribute that negative 4. Alright, let's combine like terms on the left-hand side of the equal sign. So 2n plus 1n is going to be 3n, or 2n squared plus 1n squared is going to be 3n squared. And then I have 4n plus 2n plus 1n, that's going to be 7n. And then I have this plus 2 is equal to negative 4n minus 4. Alright, so I see the quadratic. It's not going to go away this time, so we are going to have to get everything set equal to 0. So that means I need to move this negative 4n and negative 4 to the left. So now I'm going to do this all in one step. So I'm going to add 4n and add 4 to both sides. And make sure you add them to their like terms over here. So I am going to get equal to 0 on the right hand side. On the left hand side, I'm going to have 3n squared plus 11n plus 6. Alright, so we have to factor this, which is bottoms up. So multiply the 3 times the 6, and we'll have n squared plus 11n plus 18. Factor this, and that's going to factor into n plus 9 and n plus 2. Divide the 3 back out, and we're going to get n plus 3 and 3n plus 2. So on the left hand side we have n plus 3 times 3n plus 2. Take each one of those, set them equal to 0, and solve so we'll have n is equal to negative 3. Over here we have a two-step equation, so we'll have 3n is equal to negative 2, and then if we divide by 3, we get n is equal to negative 2/3. So our two answers are going to be negative 3 and negative 2/3. And again, I know that because I have a quadratic, so you should expect two answers. Alright, so let's look at an application problem. This is a word problem, and just know on your test you will see some word problems. The setup, the formula that you need to write on your 3x5 index card is this. Rate is equal to quantity over time. Rate is equal to quantity over time. So let's look at this problem. If Shayla can paint one chair in 45 minutes, and her sister Jamie can paint a similar chair in 60 minutes, how long will it take them to paint a chair if they work together? So let's look at this equation. The setup is going to be Shayla can do one chair in 45 minutes, and Jamie can do one chair in 60 minutes. And so the question is, how long will it take, so we're looking for time, how long will it take them to paint the chair if they're working together? One chair working together. And since I put this plus sign here because they are working together. If they're working against each other, or if you have a problem where something's working against each other, then you would put a minus sign here. Okay, so at this point you can use our technique of multiplying through by the common denominator, or you can just use your calculator and put those fractions together and then solve that way. It's completely and totally up to you. I think I'm just going to add 1 over 45 plus 1 over 60. And we're going to get 7 over 180 is equal to 1 over x. And so now what we have is a proportion, and we know how to solve proportions, so we have 7 times x is going to be 7x equals 1 times 80, or 180 is 180. And then if we divide by 7, 180 divided by 7 is going to give us 25.7. So it should take 25.7 minutes for them to work together. And when you do these problems, check your answer and make sure they make sense, because if Shayla can do it in 45 minutes and Jamie can do it in 60 minutes, then it would make sense that if they work together, it's going to cut the time down. By how much, we have to solve the equation, but if they're working together, it is going to take that time down. So make sure your answer makes sense. Alright, last one. We have an inlet pipe that can fill a tank in 10 minutes. So we have a pipe coming in, and it takes 10 minutes. There's also a drain that can empty the tank in 12 minutes. If the tank is empty and both pipes and drain, both the pipe and the drain are open, how long will it take before the tank overflows? Okay, so we're talking about one tank, but we have two different pipes. One pipe's going in and one pipe's going out. So one pipe is filling the tank and the other one is draining. So they're working against each other. So I need a minus sign in this particular problem. But we're talking about one tank. The inlet pipe does one tank in 10 minutes. And then the drain pipe does one tank in 12 minutes. And so the question is, how long, we're looking for time, how long will it take before the tank overflows? So again, we're going to do the subtraction. So we have 1/10 minus 1/12, which is going to be 1 over 60. And again, you don't want a negative number here, so if you come up with a negative number, just turn them around. And then we're going to cross multiply, and so we're going to get x is equal to 60 minutes, or 1 hour. So this one's not that bad. You just need to remember quantity over time. Quantity over time, and then if they're working together, that you're going to add. If they're working against each other, you need to subtract. And of course, always make sure that you know what the question is asking for. Alright, so I want you to complete these numbers on page 230 and bring them in